Let's just.
The baby pendulum.
Hey, I need you guys to pay attention real quickly, because the reason why I gave my demerit 8 period is because I felt like there was a particular student that had no fear of me, which sounds like every one of you in this class. So,
I fear.
Demerits for everyone. Freshman year, everyone gets demerit. It's not
Yeah, let's.
What's Lars?
Everyone in the entire school is super
yes. Oh, really? Hold it.
Damn.
Okay.
It's only still not different.
Okay. In simple harmonic motion, the maximum displacement from equilibrium is defined as the amplitude. Okay, I'm going to give you kind of a crash course for those of you who have yet to take advanced chemistry. Everybody else, this should be review.
Sorry, this
We're getting into the idea of sine waves here. Okay, and we're going to talk about 3 particular variables. We're going to talk about amplitude, we're going to talk about frequency, and we're going to talk about period. Okay, so amplitude. Okay, in the definition of when we're talking about simple harmonic motion, the amplitude is how far you are away from equilibrium. Okay, so your amplitude, your greatest amplitude would be at your furthest away from equilibrium. Okay, well let me just, I know this is kind of not a straight line, so I'll try to do my best doing this at an angle. What do you think up here refers to the amplitude? Any ideas? Yep. So if this is equilibrium, this is the furthest away I get from equilibrium. Does that make sense? Since that's the furthest away I get from equilibrium, that has to be my amplitude. Okay? Alright, those of you who took advanced chemistry, frequency, do you remember?
How many, or like how often?
Remember this from my team.
Okay?
I remember this from.
So, frequency is how tight your cycles are, essentially.
Measured in hertz.
Okay, so let me show you a different example, and it might make a little bit more sense. Okay? Frequency is going to be how many cycles you are, how frequently they.
That's what I tell frequent.
It's
It's the amount of bumps in a given second.
Yes.
the peaks.
Well, no. Yes.
Like how many waves are there?
Okay. No. Okay. Yes. So frequency is going to be how many cycles you get per second. Okay. So the tighter. So which one would have the higher frequency then?
The bottom. The
The bottom one, because you would
bottom.
have more cycles in a unit time. Okay. So amplitude is how far you are away from equilibrium. Frequency is how many cycles you have per second, and period is going to be how many. Why am I drawing a blank?
Time it takes to complete the
Yes.
cycle.
Time it takes to complete one full cycle. So let me explain what one full cycle would be. One full cycle would be from peak to peak, or what is this called?
Oh!
Trough to trough. Okay? So if I go from here all the way through one cycle, the time it takes to go through that one cycle is going to be your period. So there's going to be a relationship between your period and your frequency.
Yeah. Isn't that like essentially the same, but like not?
They're inverses of
If
each
you
other.
draw exactly where the frequency would be, or is that not a distance?
No, frequency is not a distance. Okay? And we have not introduced this, and we probably don't need to right now, but I'll just give you another example. From peak to peak, the distance between them has a name too. Does anyone know what that's called?
Yeah, that's the.
Isn't that?
Nice.
Oh,
Yeah.
Starts with a W. And
Wavelength.
Wavelength. Okay? So what you have, amplitude is the distance you are away from equilibrium. Okay? Frequency is how many cycles per unit time. Period is going to be how much time it takes to do one full cycle. And your wavelength is the length between your peaks and your troughs, and they should be the same. Okay? So, we've really talked about two things in simple harmonic motion. We've talked about a mass spring system and a simple pendulum. Believe it or not, they're a little bit different when trying to figure out your period and your frequency. Okay, your SI units for amplitude are going to be in a meter, and that should make sense because it's essentially the distance between your equilibrium position and your max displacement. So it makes sense its unit would be a meter. Okay?
Rad.
Alright, so we already kind of talked about what these were, but here are your units for period, because we said the period is the time it takes to complete a cycle, so it would make sense that we would need a time unit to quantify that. And secondly, your frequency is going to be at the unit hertz. Anybody know what that's derived from?
You said it's like an inverse something.
Inverse seconds. I said that, remember how I said just a second ago, that your period and frequency are inverses of each other. So if you're, what?
What?
You said a second.
What did I do?
We're making a science joke.
Okay, so period and frequency are inverses of each other. So if a period is seconds, the inverse of a seconds would be inverse seconds. Or seconds to the negative 1.
So when you said,
So a hertz is a second to the negative first power.
when you said something a second ago, you said something.
Wait, so there's an inverse of 21,400 hertz.
Remember when I said it?
Right.
Oh.
I think
Bad explanation.
So here's the relationship.
Mr. Kramer.
Yes.
What does it mean, like conceptually, that period and frequency are inverses of each other?
What does it mean conceptually?
Yeah.
Boy, that's a really broad statement or question.
I don't know, every time we say that, you're just gonna say.
Opposite.
Y-A-T.
So like if you have 1/2, the opposite of that would be 2.
So if you have 1/2 period.
From mathematics.
Is it hot in here? No. Guys?
So like,
It's like the
when I take the inverse of something, I take the reciprocal of it.
Oh, yeah, okay. HB.
So if I have a second, the reciprocal of that would be 1/2, which would be the same as an inverse or a second to the negative 1 power. Right? Makes sense? A little better?
S.
So, what's nice about that is if you know the frequency, you should be able to determine the period. And if you know the period, you should be able to determine the frequency. Because they're inverses of each other. Okay? Okay. So, do you guys have this visual in your notes? Can I give it to you? Okay, so this kind of gives you the definition of each of these terms and a kind of an example. Okay, you can see amplitude would be your max displacement from equilibrium. Your period would be 1 full cycle. Your frequency would be how many cycles you could get in a certain time unit. You could choose whatever time unit you wanted, right?
Years.
That would be an outrageous amount of cycles, but that's okay.
Does that mean we're going to have to?
No, you will not put your calculator in radians. All right, so, what? I'm sure there's a relationship, I don't know what it is.
Wait, why does it have K in our notes?
It has free fall acceleration. It has the letter K.
No, it doesn't.
Look
Yeah, it
up.
does.
Look
What
up.
about the top one?
Yeah, that one. Isn't that that one? Oh.
Now that is like, okay. So when we have a separate equation for the period of when I'm dealing with a simple pendulum versus when I'm dealing with a mass spring system, okay? Even though you're solving for the same variable, you've got different situations, so they depend on different variables. When you're dealing with a simple pendulum, what's really the most important variables are going to be the length of your string or whatever it is you're dangling your bob on. Okay, and your gravity. Okay. So what if you notice? It does not depend on what the mass of the bob is or what the amplitude for small angles of that bob is. Okay? So just know that you have to identify if you're doing a simple pendulum problem or if you're doing a mass spring problem, because they're not solved exactly the same way. Because they depend on different variables.
So identify variables.
Yep. Sounds like physics. Okay? Then your mass spring system depends on the mass and on your constant. It should make sense why it would be dependent upon your constant. Because your constant is going to tell you how much of the spring force you're going to have and whatnot. Okay? For this one, does not matter how far you are away from equilibrium, and here's why it doesn't matter how far you are away from equilibrium. Like, equilibrium. Okay? So, the further away I get from equilibrium, the greater the what? Potential energy, okay.
The greater the weight.
Greater the force.
The greater the force, right? Okay? So, whether I'm a long ways away from equilibrium or a little ways away from equilibrium, the force that is given by that is going to be proportional for each. So that's why it does not matter how far away from equilibrium you are when figuring out the period. Okay? Alright, and it does have to follow Hooke's law, but like everything in physics, we're just going to stick to the easy stuff.
Yeah.
Simplified is the bestified.
Everyone always knows.
Alright,
So physics is the
problem.
easiest class in the world.
Great. Thanks.
Now we're gonna tell everyone Kramer.
Well, to be fair,
Wow, I dropped chemistry actually, and I ended with a
guys, turn your head. Turn your
A
head.
minus.
It's a face.
The face.
Or you can also look at it like that. It's a phase two.
No, my face matches up. It's a face.
They will find anything.
Is that a circle?
What if I gave you enough demerits?
No, the new
What if I gave you enough demerits to make it so you couldn't go off campus?
I didn't. I
You're laughing at
I
our
hate.
face.
I hate.
Spherical objects.
It's
It's
not funny. Turn your head.
You can totally do anything and see when
Yeah.
something says bright as the roll, that would shut that right when it shuts.
I didn't do anything. Especially.
Especially.
I only sit in the front row. For
Well, at least Cole has fear of me.
Yeah.
I fear you.
He doesn't fear you. He fears what you do.
Cole,
I fear your power.
Anyway.
Cole.
Right now. Just saying people
So, first off, this problem. What type of simple harmonic motion are we dealing with here?
Pendulum.
Pendulum, okay? So we need the pendulum equation. What does the pendulum equation depend upon? What variables are
Length and
length and acceleration?
One's for a spring.
Everything depends
size of it.
No, it doesn't. Oh, yeah, it does.
No, that a pendulum.
What about T?
T equals what?
2 pi.
Oh, shoot.
Oh, but 2 pi at the end is the same thing.
Yeah.
2 pi radical L H. What is
Pi.
Omega.
Yeah, it's omega. Frames, it's fine. Just keep
No,
going.
no, please keep going.
What are you talking about?
What is that pi?
It's fine.
Anyway,
You guys are so
Barrett.
You need to know the height of the tower, but darkness obscures the ceiling.
Pi.
That's a pretty funny problem. No, you're laughing.
I can't
There's
hear you.
smoke in the room. Okay. You know that the pendulum extending from the ceiling almost touches the floor, and the reason why they say that is so that you can figure out the length of the ceiling by knowing the length of the.
What building has a dangling object from the ceiling of the building?
The science-
When have you realized that nothing we do in this class is important?
Oh, the sciences are out. There's people.
On video.
And I always look up there like, where's that? Yeah.
Are they still up there?
In respect, I'll put down my
Okay.
T for you.
What variable do we know?
Time.
For the period.
Okay, the big T isn't time, I'm sorry.
It's period. It's IoT.
How tall is the tower? Okay.
Real tall.
Do we know AG?
Absolutely. It's
It's
that's
a
why
charge
it's
due to
9 seconds
gravity.
per second. It's actually.
We know pi.
I want to know.
He put positive.
22 over 7.
Why is it's the constant.
Oh,
it's not the negative. But when you're applying it to like gravity force, then you plop a negative
You know,
on it.
2 pi.
Plop negative.
Hey, is 22 over 7 actually correct for pi?
Yes, it's more correct.
This doesn't matter.
Guys, can I know you guys don't like this, but can I manipulate the equation before I plug in the variables?
Yes, that's very much better.
Sorry. So, T divided by 2 pi. Would you agree with that assessment?
Yes.
Okay.
I'm actually
Squared
Correct.
L over AG.
Yeah.
lag.
Multiply by 8.
Yeah, that's how we do it.
Lag.
Lag.
Wait, wouldn't she also go through everything?
Max, I'm sorry, don't say it.
Yeah, okay.
So,
But then I went shop for
He just manipulated. Is it the was it's on?
Go ahead, plug
okay.
in
Plug and chug. Because what you're finding when you find L is, yes, you're finding the length that's of the string that's holding your bob, but it's pretty much the height of the.
Yeah.
What about
Height of the
diameter
inside of the
of
ceiling.
sphere?
That's a short
What
tower.
if the bob is like an atom?
We don't live in a what if world.
How do you dangle an atom?
It's just.
Okay, in the science center, that's question.
Yeah.
I don't know, I've never done
Nope. What?
Wow.
You've been to the science center? We're tasting you.
They-
Are you?
Pass.
Yeah, yeah,
I did have.
When you plug in your variables and plug in your numbers and do the math, what do you get?
You have
I
lag.
got a point.
We can build Lego cars together.
Why not?
We can do little water
Like,
things.
Yeah!
I got 18.
I'm
35.8.
I got 36.
Yeah, you got
35.8.
And 36, you're right.
I'm gonna read
I did not square it.
Oh, dude, I saw the best idea. You know, like the little blanket you chew off? What if you just like tape a paper and put to that at the bottom of the tube?
Did those of you who got it wrong, did you figure out what you did wrong?
I don't
I'm
know.
assuming it's a
what
calculator.
Probably, which would be either.
Honestly, no, I can't figure it out. 36.
Just answer.
Kramer.
How the frick is 12 divided by 2 pi 18.84?
You gotta put parentheses around it.
I put parentheses
No,
around.
around.
It's gonna say 12 divided by 2 multiplied by 4.
Yeah.
Or multiplied by 5.
So look at
That's
Oh,
the
you
answer.
should have said
That's the answer.
Bye bye. Another parentheses.
You still got the same answer.
Yummy.
Wait, what's the answer? Oh, go to so.
Do it, Cole.
That's. Wait, you.
Then I did that, and I squared it.
No, you
That's dumb. It's so dumb. I can't believe you took
Oh
that.
my god.
Well, this isn't my work.
Divide.
My guys and I did that before 19.
Maybe it's smart to use it.
Square that.
Hot.
Why are you using because of the thing you just.
Okay, any other questions on this? Pretty simple?
Nope.
Okay, this one.
Oh, now we do the spring one.
Wait, spring
boy.
Wait a
Oh.
second.
You can get
On the
the
wrong one.
You did it the wrong way?
I put it on the back.
Same.
Okay, this is a real life example right here. Body of the car is supported on a frame by 4 springs. What are those springs called in real life? Okay. 2 people riding in the car have a combined mass of 153 kilograms, so there's nothing else in the car.
Are they kids?
Nothing else in the car. Why is that important?
Because otherwise you have to add that.
Unrealistic though.
When driven over a pothole in the road, the frame vibrates with a period of 0.840. For the first few seconds, then the vibration approximates simple harmonic motion. Find the spring constant of a single spring.
Wow. 5 by 4.
Why do you divide? We need to find the mass.
Because it says 4 springs.
Yeah, I got
The car has 4 springs.
We need to find the mass here. This is where it gets a little tricky because I'm trying to find the spring constant of one spring, although it should be the same for all springs, right? Okay? So we need to find the mass distributed on just one of the springs. How would we do that?
Depends on what people are sitting.
No,
Wait, don't you?
You add the two masses
You add the masses and divide by 4.
Yeah.
What'd you divide the end result by 4? Is that
That's the same thing.
Okay, good.
Yes, guaranteed to be the same thing.
Yes.
Oh, we should bet.
So, remember in physics, we assume everything's mass is at the center of the mass of object. In a vacuum with no friction. Okay. So, each spring should theoretically, on a good day, hold 357 kilograms. Now we know technically that's probably not true, depending upon where the people are sitting. Okay, so we figured out the mass. We know what other variable?
Time. No, the period.
Actually.
Learn what?
They have to divide by how many springs there are.
Well, we didn't learn it, it's just the situation that the problem calls for.
I would.
Yeah, like if you think about it, if it wants to know one spring's constant, you would have to know the mass on one of the springs.
So we'd have to assume that all the springs
Yeah,
are
let's
exactly the same.
All exactly the same, and that all the mass is equally distributed. But otherwise, it would be an outrageously difficult problem.
When you do it, they gave you a.
I like those types of problems.
Stop. So, since we're dealing with a spring, we got a new equation. T equals 2 pi
Root square root.
Look at that pi.
mass divided by
Okay. Spring constant.
Right. This one's going to take a little bit more work to manipulate, not much. It's similar, but there's one little difference. Divided by 2 pi squared equals m over k.
Now you got it.
Then I'm going to take the inverse of both, or the reciprocal of both. You could do the cross multiplication method, but I think it's easiest to take the reciprocal of both. So you've got 2 pi over t squared equals k over m. And the reason why I did that is so that my k variable is on the top of a fraction and not on the bottom, because what ends up happening for most kids is they leave it on the bottom and then miraculously it appears on top.
So I like to see.
You know what I'm talking about? Okay, so then you would take, so what you would do is you would divide by m and you would not change k, it would stay on the bottom, then all of a sudden it would end up on top. That's not okay. So here, we have to multiply by m instead of divide. Now it's just plug and shove. That's a big number.
What's the?
Oh, I
Should be.
have the same answer.
That,
I did it from where? But.
well, that,
But cross
you
multiply.
can do it.
Yeah, yeah, but I thought I did the thing.
I got 80,000.
You probably did cross multiplication, right? The answer is 2 times 10 to the 4th.
Before changing it, I just.
Nice, Cole.
I just did multiply by
What are you doing
k.
this?
Yeah, I moved k to the other side, and it's all for m. That way.
You got 19,000.
How did you solve for him?
Because we already knew 0.84, so I was like 0.84 over 2 pi squared multiplied by k. And so I did all this together.
Oh, you solved
And
it.
then divided
Divide K here, divided that.
it just seemed different. It seemed like I did the same thing you were talking
No,
about.
because you moved it off the bottom.
Oh wait, also,
Average like 5 to 6% higher on the test, but actually.
they have the second.